And we're live. Welcome to
Woo!
2025.
Oh,
Happy
that
New
just
Year.
sounds creepy
Happy
and
New Year.
strange.
New
Yeah,
Year,
Happy
new
New Year,
stuff.
everyone.
Well, since we're at the beginning of the year, we figured it would be a good time to go back to square zero, I guess, or square one, depending on your math.
Square
And
zero, we're computer people.
yeah, kind of just, revisit the basics and kind of get the language back down so that for folks who are new or folks who've been using it, everybody has something to learn here, and we can kind of reset the language and talk about things that are important, within Service Mesh and especially Linkerd. So I'm going to go ahead and turn it over to Flynn, and we'll go.
Excellent. Yeah, we realized that in 2024 we'd spent a lot of time talking about, oh, here's a new feature you can play with. Oh, here's a new thing. And it's been really a long time since we've talked about why are we here? What are we doing all this for? What's the point? And that seemed like a pretty good way to start 2025, actually. So this is the 2025 kickoff back to basics, aka Linkerd 101. That's the name of the repo. I'm Flynn. I'm a technical evangelist for Linkerd. Tom's a field engineer. He'll keep me honest as I go through stuff or something like that. Our agenda is very simple at the moment. What is Linkerd? Why should you care? What's the point? And then we'll go into a demo. Now, much of the time we do Service Mesh Academy, we do kind of light on the slides, and then we have a longer demo. This one's kind of backwards. There are a lot of slides because we're talking about basic concepts that we want to make sure are hopefully clear for everyone. And then we'll still go through and cover a fair amount of the demo. So everybody keep your fingers crossed for everything going smoothly. Tom and I were talking earlier about how our last Service Mesh Academy, I ended up with my camera vanishing partway through. So fingers crossed that doesn't happen again. The way you can follow along, hopefully that QR code still works with my name over it. Unless, Tom, maybe you can turn the name off while I'm talking about this. There is a Git repo for the sources here. GitHub.com, Buoyant.io, Service Mesh Academy, the Linkerd 101 directory. That has been updated. It actually has the latest and greatest code that I will be using to follow along. I will be using Buoyant Enterprise for Linkerd 2.17.0. You are certainly welcome to do that. You'll need a free Buoyant ID from enterprise.buoyant.io to do it. It's very quick to get. It's cool. I promise you we won't send you spam. Everything that I'm demoing here will also work just fine in Linkerd open source Edge 24.11.8 or later. There isn't a later one right now, but maybe there will be later, if you're watching this in the future. I will also be using a K3D cluster on my Macintosh. Nothing about this demo is specific to the kind of cluster I'm using. Any cluster should work fine. There's one place in the demo where we'll be talking about actually accessing services in the cluster. And so you may need to go through and play with that part to see to get that to work for whatever kind of cluster you're using. We'll call that out. It'll be fine. Okay, with that, let's go ahead and get into it here. Oh yeah, sorry. These are the tools that I will be using at various points throughout this. So these are also great things to install. These are great things to install in general, whether you're talking about this demo or not. Okay, so what is Linkerd? Linkerd is a service mesh. A service mesh is an infrastructure layer providing security, reliability, and observability at the platform level uniformly across your entire application. The important bits here are that it is infrastructure. It happens down below the layer of the application itself, underneath, uniformly across the whole thing, so that the people working on the application don't have to think about it.
Mm-hmm.
Typically also, the people working on the application have their business goals that they want to worry about. They don't really want to think too much about infrastructure-y stuff. And one of the other nice things about the service meshes is that since it's infrastructure, you can have a separate team of people worrying about that, owning the mesh, keeping it happy, paying attention to its care and feeding, not bothering your application developers. Meshes mostly exist historically because of this transition from the old monolithic architecture to the microservices architecture. If you look back in history, we had these monoliths that we used to use, and some people still use, where you were fundamentally dealing with a collection of functions interacting with each other in a single operating system process. Let me take a moment to point out that everything I'm about to say has exceptions in the real world. The purists will be sitting here going, oh, but you could have multiple processes that interact with shared memory. Yeah, you can. That's fine. But most monoliths were just one binary, one process, one address space. And all of the monoliths relied on the operating system to isolate them from the rest of the world. That was their primary security mechanism. Usually, monoliths ended up being owned by a single person or a single team who was in charge of release engineering, right? Getting the whole thing built and pushed out to the rest of the world, or running it as they needed to. Everything was compiled and released as a single unit, and any change to the monolith requires that you completely rebuild the monolith. Being owned ultimately by a single person or team has upsides and downsides. Being built as a single unit and having to rebuild everything for a single change is mostly downside when you get down to it. The microservices architecture was aimed at making this better. It certainly makes it different. I think it makes it better, although the jury's out on that in some cases. The idea here is that instead of a collection of functions within a process, you have a collection of microservices that interact over the network. So you're going to have multiple binaries, multiple processes, usually running on multiple machines. And usually each microservice, or maybe each handful of microservices, is owned by a separate group of people. And importantly, each microservice, I'm having a hard time talking today. I don't know what it is. Each microservice will be developed and released independently of the others. This is a detail that turns out to be critical. If what you have is a case where you have microservices, but you have to build all of them and release them in lockstep, that's not the microservices architecture. That is a distributed monolith. The way microservices help things work really well is by giving you an independent release stream for each of the microservices so that you can actually develop at scale as well as running at scale. Tom, were you going to?
Yeah, and like the old world, a lot of these microservices aren't owned internally. They're either brought to you by a vendor, or it's open source software that you decided to adopt, or so the same problems apply that in the old world. The great thing is that now, you're not pinning them to a single physical machine. You're pinning them to a single network namespace, which is similar to before, right? So similar, different, but yeah, when you talk about someone owning it, it doesn't necessarily mean internally. You may have zero control over that code.
You may, and that's often
need
okay
ways to kind of manipulate that, right?
Yeah. The independent release stream, though, that is a really critical thing going on in the microservices architecture. Mm-hmm. We know how to work as an industry with like 10 developers. That's not hard. At 100, we have some ways that we kind of make that work. Once you get up to like 1,000, the microservices architecture is pretty much the only way we know to make that work efficiently in practice and actually get some wins out of it. So this turns out to be a big deal.
Yep.
Now, the really fascinating thing about the microservices architecture is that the microservices are communicating over the network, and the network fundamentally is insecure and unreliable. I do not mean most people don't implement networks correctly. I mean that these are fundamental characteristics of the way real networks are built, the way they operate. It is not a thing that you can change. And yeah, I am being told also that one of my coworkers tweaked one of the things about this slide. So you're going to get a quick look, or sorry, not this slide, but one of the future slides. So you're going to get a quick look behind the curtain here as I reload the deck and then keep going. Everybody avert your eyes. All right, here we go. Yeah. Since you can't change this about the network, you have to figure out a way to work within it. Mm-hmm. And the whole point of the service mesh is really to make this thing better. So, in particular, what we have here is a case where most of the meshes, very much including Linkerd, will add a proxy next to each application container in your entire application. and allow those proxies to go and take over all your communication. Like I said, most of the meshes do this with a proxy. Linkerd works like most meshes in this regard. Unlike any of the other meshes, Linkerd's proxy is the ultralight, purpose-built, ultra-fast, Rust-based Linkerd micro proxy. And that turns out to be a big deal because most of the other meshes end up using Envoy. Envoy is a fine proxy. It can do a lot of really cool things. It is not lightweight and it is not ultra fast. And if you're running 1,000 envoys in your cluster, some interesting things end up happening. Using the really tiny proxy that we have for Linkerd ends up avoiding a lot of those things entirely. Like I said, the microproxies take over all the network communication. They end up getting to mediate and measure all of the communications that are happening in the mesh, which gives them some really interesting capabilities. The first one is that since we're mediating all the communication, we get to enforce rules, we get to add capabilities. There's some really cool stuff we can do. One of the very basic ones that happens in Linkerd is also a really big deal. We just automatically do MTLS everywhere in the mesh. You don't have to configure anything to get this. It just turns on. It's honestly kind of difficult to turn off. So that's kind of a nice thing. There's a bunch of advanced load balancing that we can do, the most basic of which is that we can do request-based load balancing rather than connection-based load balancing. For HTTP 1, this doesn't really matter. For H2 and gRPC and things like that, it's a huge deal. We also get to do much more advanced stuff like multicluster communication. If you have a mesh, you can just secure communication anywhere. It's kind of cool. And we can do retries and timeouts and circuit breakers and all this other fancy stuff.
Yeah, when we were at KubeCon, a lot of folks didn't know anything about service meshes, and they would come up. And my analogy is that the micro proxy is really like your home router, right? You get this basic connection from your ISP, but a lot of folks who are more technical or have needs are like, "Hey, that's great, but I want VPN, or I want this, or I want to be able to open ports." So you put
I
another
want
fancier
DNS working in my house.
So you put another fancy router on the inside, and that gives you additional capabilities on that connection. And we're the same way. We put that little micro proxy, it's like your little router in there. And now all of a sudden you have control over that traffic. And your connection or your Kubernetes network is just a transport layer to move this stuff around.
Yep. I don't know what you're talking about though, Tom. It's not like I have 4 routers at home or anything.
Yeah,
Since the proxies are also measuring communications, then that lets the mesh provide really good observability.
Mm-hmm.
A basic thing you can do here is that it can discover and display the actual application call graph, meaning like which paths are really being used as opposed to which paths are possible. But we also get to measure and publish the golden metrics of request rate, success rate, and latency. And we get to do that uniformly, again, across the entire application. So every microservice, suddenly you get to drill down and see what's going on, which turns out to be a really big deal. We're going to see some of this in the demo.
Yep.
So the reason that this is important, the fundamental reason you should care about this, is that security, reliability, and observability are not optional. There has never been a point where somebody was developing their application to go into production who said, we don't care if it's secure. We don't care if it's reliable. You always care, right?
Someone cares.
Someone cares. Your user cares, even if you don't. And if you care, if the user cares and you don't, pretty soon they're not going to be your users anymore. You can get these things from a mesh, which is great. If you don't want to get them from a mesh, you can get them by writing a lot of application code, which is less great. Your application developers probably have things on the business side that they need to care about more than all the details of writing a really good security layer, for example. But you cannot do without them. We're a little biased. We tend to think that the right answer here is, in fact, to use Linkerd to get them rather than writing a bunch of application code. Fortunately, it seems that a bunch of people agree with us, which is kind of nice. All right. That's the whirlwind overview of what Linkerd is and why you should care. So now we're going to talk a little bit about some of the details about security. We're going to be still doing the very whirlwind overview stuff here, but I want to touch on security, reliability, and observability in particular before we get over into the demo. If you look back at the monoliths, they were protected by operating system isolation. Like I said, there was the OS drew a boundary around the address space for the monolith, and the operating system was the one responsible for policing that perimeter. So when you're writing a monolith, what you generally worry about is vectors where the attacker is coming in from outside the monolith, and you worry less about, oh, can I trust this function that I'm about to call? Because usually that function you're about to call is something that was created by the same people who wrote the first function, right? So it's just less of a big deal. There are exceptions to this again, but for the most part, the pieces of the monolith mostly get to trust each other. That does not work in the microservices world because, again, the network is fundamentally insecure. You can't make a secure network these days. I'm glossing over a bunch of claims by a bunch of companies as I say that, but we can come back to that if
You
people
can
have
make
questions.
a lot of security assumptions
You can make a lot of assumptions.
and cross your fingers.
You can analyze your attack surfaces. You can construct things carefully that might be good enough. But in general, no, the network is fundamentally insecure, and that's just the way it is. There are a few different ways that this sort of insecurity can appear. One of the basic ones is eavesdropping. You can have an evildoer snooping on anything that's happening in clear text, watching everything go by. You can have tampering, where an evildoer can change things that are in transit. What I'm showing here is the classic man-in-the-middle attack. The fact of the matter is you don't have to do anything this sophisticated. Your attacker could just be dropping noise onto a particular network link so that packets get corrupted. That's enough to mess with things. Finally, we have identity theft, where the evildoer pretends to be a legitimate workload. A lot of meshes and a lot of network security systems out there use things about the network, like your IP address, as the basis or part of the basis for identity of a workload. This particular attack, identity theft, gets much, much easier in those worlds in general. Foreshadowing. That's why Linkerd doesn't do that. Securing the network. You need something different for each of these three attacks. You can prevent eavesdropping by encrypting your traffic so that, yeah, the eavesdropper can see the packets, but who cares? They're just gibberish from their point of view. You can use integrity checking to prevent tampering, where you make sure that the packet you receive is actually correct. And you can use proper authentication to prevent identity theft. Linkerd does provide all three of these through the simple expedient of enforcing MTLS everywhere. And since the MTLS, the M is mutual TLS, that just means that you have to do authentication of both ends of the connection. Since authentication is a basic part of the protocol that we're using, identity theft becomes less of an issue. We can protect against that. Integrity checking and encryption are part of the basic TLS protocol themselves. That gives you a reliable, secure communication stream. It's also worth noting, like I mentioned, we do not use anything about the network as the basis for identity. For the most part, Linkerd bases identity on Kubernetes service accounts. There is a case where if you are extending the mesh beyond the Kubernetes cluster, we will use SPIFFE IDs. I personally kind of hope we set things up so you can use SPIFFE IDs everywhere, but for right now, service accounts are the way to go inside the cluster. But the important bit here is that the way service accounts work, we get to tie the identity certificate for MTLS to the service account in a cryptographically sound way. And so we get to rely on identity that is not tied to the network at all. All of this in the O'Reilly Service Mesh Fundamentals course, which I did, it came out last December, by which I mean a month ago. Wow, that's crazy. So that all gets covered in this one. We also talk about it some in the Buoyant Service Mesh 101 course. The last thing about security there is that those identities that I was just describing based on service accounts, they are the basis for Linkerd's authentication and authorization policy enforcement mechanisms that we'll talk very briefly about in the demo. Okay. Tom, anything you want to add on security?
No, I think you covered it. And we did have a question, in Slack about zero trust. And yeah, this is the foundation of zero trust, right? The zero
Yep.
trust is a journey. It's not like an easy button, right? So you start with MTLS, you start with authentication. You're going to build auth policies around that so that your every single request is going to be evaluated, not just, oh, all right, they got the right IP address. We're talking about every single request is going to be evaluated and only allowed if we allow it, right?
Yeah, zero trust is probably would be better named as zero assumptions about trust.
Mm-hmm.
Because, I mean, obviously you have to trust something, right?
Yep.
But one of the really critical bits about zero trust is that the concept of a security perimeter goes away. It's not, you get away from this idea that, oh yeah, once you're inside this perimeter, you can do what you want. And every request, every access, every time from every person or every workload, you check them all.
Yep.
And Linkerd is a really important piece of that.
Yeah, network policies. If you're talking about CNI, or you're talking about in general with Kubernetes, those are nice and they're a great way to wrap namespaces and to control things on boundaries. And you can use those in addition to authorization policy and MTLS and really, really hard
And
to bring
sometimes
down.
sometimes you need to use them
Yep.
in addition. Yeah.
But yeah, I mean, the more that you can look at, get more granular, and we can use these things with other concepts like HTTP routes, so we can be very granular about how we specify these things. It gives you very, very fine grained control over, what can do what with what, right?
Yep. I was also going to point out a recent feature added to Linkerd is the audit mode
Mm-hmm.
for authentication policy, which is a huge win because you can start adding policies with audit mode turned on and
Yep.
figure out what you would break without breaking it. So
Yep.
big win once you get into that stuff.
Lots of moving parts. So it's good to know
yeah.
that, hey, I'm not getting any errors that I care about at this point, and I can just make it go live.
Yep. All right, let's talk about reliability. Once again, this is not something that monoliths have to worry about a whole lot. The concept of a function call tends to always work in a monolith. If your monolith gets into a state where you can't actually make a function call, you have many bigger problems. Your function that you call may, of course, return an error. That's okay. The call return mechanism is still working, right? Likewise, if you have a slow function at some point in your monolith, then it will just naturally block execution for that whole thread until the function returns, and then we can continue on the call path. So flow control in monoliths also tends to be fairly simple. Both of these things break in the microservices world where the network is fundamentally unreliable. The simplest way that this manifests is that a network call to another microservice can fail, which means that at some point it will fail, Murphy being alive and well. But a more subtle one is that if you have a slow microservice, its clients are just going to keep feeding it more traffic unless you build in some other mechanism, because the network by itself can't do anything like that for you. These are both really simple things, but they can combine in very, very surprising ways. We're going to take a look at a couple of these. So if we have a more realistic view here, we're going to have one S1 microservice sending its requests load balanced across 3 different S2 pods. This is a thing that happens a lot, especially in Kubernetes. Suppose that one of those pods crashes. So all of the requests that pod used to be handling will now be distributed across the remaining 2 pods. That extra load might cause another pod to crash, and then all of its load will be load balanced across the remaining 1 pod, which could, of course, cause that one to crash as well. And now your entire application is down because of a single microservice failure. This is a specific example of a cascade failure. Something goes wrong in one component, but the failure is not correctly isolated to that component, and it rapidly cascades across your application as a whole. This is bad stuff. This is not a thing you would like. Another fun one that happens at this point is while we're waiting for S2 to come up, all those requests from S1 don't have anywhere to go, so they just constantly fail until the moment that one pod comes up, And then all of them get directed to that one pod, which probably just instantly crashes under the load. Again, very simple failures here, but you can end up with very complex and bad emergent behaviors. Cascade failures and thundering herds are two specific emergent and bad behaviors. There are a lot more. Dealing with all these things requires that you have you need to carefully manage your traffic based on the state of the pods that are part of your mesh. And in turn, that requires detailed knowledge both of the traffic and of the state of the pods. Service meshes like Linkerd are in a great position to have all of this stuff. Without it, it can be very, very difficult to manage.
Yeah, that's a good, interesting. One thing that you pointed out when I was getting ready to do my KubeCon talk was in-band versus out-of-band checks. Right? Kubernetes can be aware of certain things, but unless you have the observability into what's happening at the proxy level,
at layer 7,
layer 7, you might not know that there's actually something going wrong.
Yeah.
And so again, that's where service mesh, especially Linkerd, is going to help you catch things that that the Kubernetes itself isn't going to catch. It thinks it's healthy. It thinks it's fine. Oh yeah, it's still up, or condition is still satisfied, when really there's things going on under the hood that it doesn't know about.
Yeah, Kubernetes understands things at layer 4 a lot better than layer 7. So, if Kubernetes sees that the HTTP request is going through, it's probably going to be happy, even if it's doing nothing but returning 500 statuses over and over and over again.
Yep.
Linkerd provides a lot of different mechanisms to try to help make your network more reliable. We are not going to go over all of these right now. Once again, in the O'Reilly course, we do. But advanced load balancing, retries, timeouts, circuit breaking, dynamic request routing. I should have put rate limiting on this slide because we do that now. There's a lot of stuff. And where security kind of, Linkerd can do MTLS with zero configuration. Reliability, you have to tell it what's okay. For example, it's never okay for any mesh, including Linkerd, to just retry any HTTP request, right? You probably don't want to retry things that are changing state on the back of the server, for example. So you need to tell us what's okay to retry and what's not. You need to tell us at what point do you want to break a circuit. You need to tell us what kind of dynamic routing you want to do. And we're going to, again, see some of this in the demo, but there's a fair amount that you need to go and look into about this to really use them well. Finally, that brings us to observability. Since the proxies measure all of the communications, they are in a perfect place to show you what's actually going on in the network in your application. For example, like we mentioned before, since you have real-time telemetry, you can see the actual call graph for the application, where the difference between paths that are possible and paths that actually happen for specific requests can be very, very important. Likewise, the mesh can very easily collect golden metrics, success rate, latency, traffic volume, and publish all of these things uniformly across the entire application. Linkerd does this by tying all the metrics into Prometheus. The Linkerd Viz extension also provides a simple dashboard, which we're looking at right here. Integration with Grafana, if you install Grafana. Custom Grafana dashboards, which are Tom's favorite thing in all the world, are also very popular with lots of people. And again, we talk more about this in the course. There's a question I see on Slack about whether the course is available for annual subscribers. I think it should be.
Yeah, I think there's a free 10-day trial, so you have to hustle through it, right?
Well, but if you are already a subscriber, I would expect that you have access to the course as well. You should have
access then. Yeah. If you're not, then you got 10 days.
Yeah.
To try.
And if any annual subscribers try it and it doesn't work, then let me know and I'll dig into that a little bit. All right.
Yeah. I think the other thing with regard to observability is like thinking about observability in two dimensions. One's like ongoing, where you build dashboards and whatnot. And then there's the ad hoc, whether you're just querying Prometheus or you're looking directly at metrics. You want to see like, hey, is, what's going on
What's
under
going
here?
on?
Or yeah,
Yeah.
what am I seeing here? Does it make sense? So whether you're going straight to the proxy and looking at it that way, or you're using an intermediary, or again, you're like building an ad hoc dashboard, or just like kind of visualizing it that way. There's a lot of ways to get information out of metrics. It's very, very useful. Logs as well. Proxy logs are enormous, right? So it's not just metrics, but logs to see what's going on. Am I seeing obvious error messages? What does that
Enormous is enormous is a good word to use there. Yeah.
Yeah, it is.
Okay. We are going to talk about a fair amount of this as we go through the demo, and then towards the end, we'll point you at some other resources for some of these things. So, there's, again, we know this is sort of the whirlwind overview, trying to go through and give you the concepts, and we will have pointers to other resources as well. Other capabilities, things that you can do with Linkerd that are just kind of cool that we're not going to talk about in the 101 course here, but which we will be digging into in future SMAs as well. Multicluster, like we mentioned, if you are already using Linkerd to provide secure communications, you don't actually need to stop at cluster boundaries. It's straightforward to set things up so that Linkerd can secure communications between clusters as well. We've seen a lot of push over the last year or so into this world where, we used to use namespaces for isolation between teams. And now we're starting to see people just, oh, fine, here, team, have your cluster, because that way the isolation is stronger. You don't have to worry about even the possibility of your development team doing something that messes up another development team. Ephemeral clusters are becoming more common as people recognize that treating the clusters like pets really does work, like cattle really does work. So we're seeing a lot more of that, and Linkerd multicluster makes some really fascinating things really easy when you do that, which is kind of cool.
Yeah, cross cloud, hybrid, on-prem, cloud, all that kind of stuff you can do. And then again, we secure those communications.
Yep. We did the practical multicluster service mesh academy September of last year, maybe.
Yeah, something like that.
And one of the things that we do there is show like migrating between clouds, because, hey, if it's just part of the multicluster, it just works. You don't care. It's really cool. There's also the mesh expansion concept where you don't actually need clusters everywhere. You can just take some of these workloads and have them running on Linux boxes instead, which opens a lot of doors to Internet of Things workloads, legacy workloads, migrating workloads into your cluster easily. Bunch of cool stuff going on there. The Linkerd microproxy is really, really lightweight. The demos that I tend to do with it for mesh expansion, I have it running on Raspberry Pis. Works great. Zone-aware routing is a really cool one also. If you're using multiple zones within your cluster and you are not using Linkerd, you will tend to see traffic like this that's in zone, but you will also tend to see a lot of traffic like this crossing zones, because Kubernetes doesn't really pay attention to zones. And unfortunately, a lot of cloud providers do pay attention to zones. So the traffic crossing zones can get to be very expensive very quickly. If you install Buoyant Enterprise for Linkerd and turn on Hazel, all the cross-zone traffic just vanishes unless you have problems where you need to have it. Like maybe your service crashes in one of your zones and the only one running is in a different zone, and Hazel will just go ahead and allow that to work so that your application keeps running while you bring the other workload back. Yep. Hazel's really cool. It's kind of fun to play with. There are a lot more things that Linkerd can do. These are a few things that I wanted to call out just so that people were aware that they existed. This is the Back to Basics 101 course, so we're not going to get into this stuff, but keep an eye out. I expect we'll be coming back to these things in more detail later in 2025.
Yeah, and even if you're not using Hazel, you do get Power 2 Choices load balancing, which gives you a bump, and that's just looking at randomly picks two endpoints and says, hey, this one looks better. Let's send it there. So,
and part of better is latency.
Yep.
So Linkerd generally tries hard to send requests to endpoints with lower latency, and those will generally be endpoints within your same availability zone. So even without Hazel, Linkerd does better at that, but with Hazel, it's a superstar. So, all right, getting started with Linkerd. There is a 3-step process towards installing things, and I'm sad to report that bit about Helm should have showed up a little bit later in this slide. This is how you know we're doing it live. First off, you're going to install the CRDs for Linkerd. After you install the CRDs, then you can install the Linkerd control plane. And then after you install the control plane, you can mesh your application. You can do this with Helm. You can do it with the Linkerd CLI. If you're doing Buoyant Enterprise for Linkerd, you can also use the Buoyant lifecycle operator. We strongly recommend that you do not use the CLI for production use, but we're going to use it in the demo because it makes things really easy for demos. Brief digression. If you are using Linkerd and you are also using some other project with Gateway API, this becomes a 4-step process. You will want to install the Gateway API CRDs first, and then the Linkerd CRDs, and then the control plane, and then mesh your application. The reason for this is that the Gateway API CRDs have to be shared between Linkerd and whatever other Gateway API consumers you're using in your same cluster. And version skew is a real problem. If you allow different projects that you're using to install Gateway API CRDs, they can install multiple versions that step on each other and bad things happen. So if you are using multiple projects that use Gateway API, your best way to deal with this is install the Gateway API CRDs by hand, and then don't let anybody else mess with them after you install them by hand. We are not going to show this in the demo, but I did want to call it out because it has been the source of much frustration actually out in the real world. Okay. That's actually it for getting started. Getting started with Linkerd is really easy. You can get it running. Well, you're going to see how long it takes me to get it running in the demo cluster, but the answer is a small number of minutes. For the demo architecture, we will be using the world famous Faces demo, which you can find at github.com/buoyant.io Faces demo. The Faces demo exists to show you a grid of faces in a web browser. There you go. That's a QR code that will take you to the Faces demo GitHub URL. We start with the Faces demo with a cluster and a web browser. The web browser will be running our Faces GUI. For each cell that you saw in that screenshot, the Faces GUI will talk to the face workload. Face will request a smiley from smiley and a color from color. Normally, smiley is supposed to return this grinning smiley. Color is supposed to return this blue color. And then face comps the two together, and that is what the GUI is supposed to display. Face talks to smiley using HTTP, but it talks to color using gRPC, just so we get to show off Linkerd's skills with both of those. In our demo today, we will have a smiley2 workload that returns a hard eyes smiley, and a color2 workload that returns the green color. We're not using both of those at first, but we will be later on in the demo. Also in the demo today, we are going to do something that is at best described as blatantly cheating. Rather than install a proper Ingress controller and configure it and burn all the time on that, we are installing Faces in a mode where it uses the Faces GUI workload, which serves the HTML for the GUI. We're basically telling it to pretend to be an Ingress controller for us. For most situations, this is a terrible idea, but for the demo, it works really well. Finally, of course, we have Linkerd everywhere. So all of our workloads are meshed, even smiley2 and color2, even though we're not using them at the start. And with that, it's demo time, unless there are any questions that haven't been handled yet, Tom.
I think we're good.
Awesome.
There was a question about what versions of CRDs are supported, and I said that we can go up to 1.1.1 experimental.
Yeah, the only other note about that is don't use Gateway API 1.1.0.
Yeah, that's a good point.
Actually, don't use Gateway API 1.1.0 anywhere. It has a bug in the gRPC route that can cause problems. If you're using Linkerd and you want to use Linkerd collaboratively with other Gateway API projects, I would strongly recommend 1.1.1 experimental. That's the way to go for right now.
Yep.
All right. So in this workshop, we're going to go through a bunch of the things that we just went through in the slide deck, but we're kind of going to do it through the lens of installing a horrible, broken application. You will have noticed when I showed the screenshot of Faces, a lot of the stuff on there was not grinning smileys on blue backgrounds. That's because Faces, when you install it normally, deliberately fails a lot of the time. The point of Faces is actually to show off just how complex things can get, even with a very small number of microservices. So we're going to install the Linkerd the Linkerd CLI. Then we're going to use the CLI to install Linkerd into our cluster. Then we're going to install Faces. Then we're going to use Linkerd to figure out what's going on with Faces. And then we're going to use it to make things better with our broken application. So to get started, I'm going to make sure that our cluster is in fact empty. That looks pretty empty. Excellent. Let me point this out. It's in the README, but just in case, for the love of all that is holy, do not run this demo script against your production cluster.
Mm-hmm.
But go make an empty cluster and play with that. Okay. So for this workshop, like I said, I am using Buoyant Enterprise for Linkerd 2.17.0. If you want to use Bell 2.17.0, you will need to go sign up for a free account with Buoyant. It'll take you a couple of minutes. I promise you we won't sell your information to anybody. It's not a big deal. It's good stuff. You will need the Buoyant license environment variable that you get when you sign up for that. If you really don't want to go through that, you can also use Linkerd Edge 24.11.8 or later. So here we go, installing the Buoyant Enterprise for Linkerd CLI, which we do by using curl to fetch the installer, and then we pipe it into SH. This business where I am explicitly setting the Linkerd version is because of rank paranoia, where I want to pin the version in case somebody comes back and runs this 6 months down the road.
Mm-hmm.
If you leave off that env and just pipe it to SH, it'll work fine. You'll just get the latest and greatest. So there we go. We have that. I have to go through and set up my path correctly to make sure I actually have the Linkerd command available. And then I will run Linkerd check -- pre to make sure that my empty cluster is actually capable of running Linkerd. This, with the green check mark and green check marks all the way through here, that's what we want to see. That tells us that our cluster is good to go to install Linkerd. Next up, we need to install the Linkerd CRDs. We will use this command to do this, and this is a common idiom with Linkerd. The Linkerd CLI won't actually touch your cluster. The Linkerd CLI will produce YAML as output, and then you can do what you like with the YAML. You can modify it, you can check it into Git and use GitOps, you can do whatever. In our case, we're just going to pipe it directly into kubectl apply to apply it to the cluster. So let's go ahead and get that done. That's exactly the same command. I'd like to point out that in this case, we did let it go through and install some Gateway API CRDs for us. And that is an excellent time to start our running tally of places that the workshop is deliberately simplifying things from the real world. Number one, we're letting the Linkerd CLI manage the Gateway API CRDs for us. That's because the demo isn't using any other project. And so we can do it the easy way and just let Linkerd do it for us. But if we were going to have Linkerd and, say, a Gateway API Ingress controller in here, we would want to run to control the CRDs by hand ourselves, and then tell Linkerd, the CLI, hey, don't mess with these CRDs anymore. Okay. After that, we have the CRDs installed, and now we need to install the control plane. The way you install the control plane is you run this remarkably similar command as the last one we did. The difference is it doesn't have the -- CRDs switch anymore. And then after that, we're going to run Linkerd check without the -- pre-switch to make sure that everything got working okay. When we run this, you'll note that it will run and return pretty much immediately. It does not wait for Linkerd to be running, but Linkerd check will do that for us. This is a fun part of every demo because this particular step of Linkerd check is always one of those things that takes just long enough that I get afraid it's not going to finish. So actually, it took a lot less time than I was afraid it would there. That's really nice. So status check results are green check mark again. If we scroll back, we can see all green check marks through here. That's what we want to see. And now we have a happily running Linkerd in the Linkerd namespace in our cluster. So if we get the namespaces, you'll see that, look, there's a Linkerd namespace. And if you look at the pods, these are the normal things that you expect to see for a Bell installation. The kind of in reverse order, the proxy injector is responsible for noticing new pods appear that have been annotated for inclusion in the mesh and sticking the sidecar proxy into it. The identity controller is responsible for managing the identity certificates that go along with MTLS. The destination controller is responsible for routing and policy decisions, broadly speaking. And I'm not going to lie, I don't remember exactly what the enterprise controller
we
does.
split
What
out
does the enterprise controller do, Tom?
We split out the functionality for like license checking and things like that into an enterprise controller.
Excellent. And I totally didn't ask that question because I wanted to take a drink. I would never do such a thing.
Do it. Yes, and this is not an HA installation, right? So for folks who work in production environments, they're like, "Whoa, there's no redundancy." It's like, "Yep, this is basic," right? And if you follow the instructions, if you go to docs.buoyant.io, there's instructions out there for different ways to install. With it, you can do it with Helm, you can do it. There's a lot of ways, but an HA deployment is what you're going to want to put into production environments. You're not going to want to only have single components here. Yep. This is just very simple and easy to understand.
The reason we didn't do an HA environment, by the way, is that you can't do an HA deployment without having at least 3 nodes. And I wanted to keep the cluster requirements really simple here. This is a single node cluster, so I can't actually run HA. But that is a good reminder. I'm going to add a simplification to this about HA after talking about this simplification that I just already had in here. We're letting the Linkerd CLI manage our certificates at this point. And that is also a thing you never ever want to do for real world use. MTLS is the basis for secure communications in Linkerd. MTLS requires certificates. Linkerd specifically requires a trust anchor certificate and an identity issuer certificate. The trust anchor signs the identity issuer. The identity issuer signs all the workload certs that are the basis for authentication. For this workshop, we let the Linkerd CLI silently generate the trust anchor and the identity issuer and stuff them on the cluster for us.
Yep.
Terrible idea in the real world. Don't do that. On the other hand, it makes things a lot simpler for the workshop, especially given that we're already 45 minutes in.
Yep.
So to this, we should add, as Tom pointed out, we are not doing an HA installation here. This is just a single point of failure ready installation of Linkerd. There needs to be a word for not HA other than non-HA.
Basic.
Yeah. So in the real world, you would run at least a 3-node cluster and you would go through and tell Linkerd, hey, do an HA install. And I'll go and update that in here and link back to the docs on how to do that. Okay. We are also going to install Linkerd Viz, which gives us that simple dashboard that I showed a screenshot of in the slides. This is basically the same process as installing the control plane in terms of what commands you run, except that instead of running Linkerd install, you run Linkerd Viz install. So we do that. And just like before, it installs a bunch of stuff and returns without waiting for anything to be up and running. And if I run Linkerd check, it will rip through the checks it did before. And then we will land on the Viz extension check, which is waiting for Viz to come up and run. I could also have run Linkerd Viz check, but I am not going to lie. I almost never run anything but Linkerd check itself because if I'm interested in checking a piece of Linkerd, it's probably just as fast to check all of Linkerd. That's just me. I don't know. Other people probably do that differently.
It's a pretty handy, Linkerd has a lot of the command, the CLI has a lot of different options that you can work. And so definitely take a look, use -- help and see what's
Yep.
available out there. The other thing is if you want to just do a quick check, Linkerd version will show you what you're running as far as the mesh and the CLI. And you want to kind of have those things close too.
Yeah.
So the more you work with it, the more you might get these older versions in there, like living on your machine. And you want to make sure that you're not using a really old version or mismatch.
Yeah. We support officially one version of SKU. So if you're running Linkerd 2.17 and you're using the 2.16, some 2.16 components, that is supposed to work. I personally prefer to make sure that the CLI I'm running is exactly the same version as the stuff I have in the cluster. There was something else I was just about to say about that too, and now I forget. Oh, yeah. Sorry. As you work with Linkerd, you may also run into a situation where, for example, we're running Linkerd 2.17 in this cluster. If this cluster lives long enough, this one won't, but if it did, 2.18 would come out. And at that point, when you run Linkerd check, you will also start to get warnings with yellow exclamation marks, I think it is, saying, hey, there's a newer version of Linkerd out here. You're down rev. You might want to do something about that. That's a warning, not an error. You can choose to ignore it, but don't be alarmed if you start seeing it with long-lived stuff.
Yep.
So at this point, we have Linkerd Viz. It's running. We've got a Linkerd Viz namespace now. We have some stuff running in here for Linkerd Viz. For those who are curious, usually the Prometheus installation is the one that takes the longest to come up. And we can go take a look at the dashboard in a web browser. Pardon me for a moment while I mess with my web browsers. So there you go. There's the Linkerd dashboard, Linkerd Viz dashboard. It's not very interesting right now because all we have are, Kubernetes namespaces and Linkerd. But hey, Linkerd has 100% success rate. Yay!
Love it.
So, that's good. That's definitely not a bad thing, right? This does, though, let us call out another simplification, which is that we just let Linkerd Viz install Prometheus for us. All of the metrics stuff in Linkerd is based on Prometheus. The assumption is that you have a working, reliable, good, high-quality Prometheus that Linkerd can go and cram all the metrics into, and that Viz can query for metrics and all that stuff. The Prometheus that Linkerd Viz installs is not a high-quality Prometheus. It is configured to keep all of its metrics in memory, which means that as you add more metrics by running Linkerd and doing things, it will consume more memory. Eventually, it will get killed and die and restart, and all of your historical metrics will vanish at that point. Please note I said will, not may. If you are using the Viz Prometheus, I will personally guarantee you that you will absolutely lose metrics regularly and more frequently than you want to. So don't do that. Install your own Prometheus and use it for Viz. And we have instructions on how to do that.
Yeah, and in production, it's not going to handle production level workloads as well. It's not really scaled for that, right?
It's really not.
So I'm going to throw the bring your own Prometheus instructions up here, and that'll help you figure out, how to get around that and start building a production ready Prometheus deployment.
Yeah, we're actually doing some work on the bring your own Prometheus instructions too. We'll
they're going to evolve.
They should improve, and I have a funny feeling that we may well end up doing a Prometheus SMA in the 2025. Okay, we have Linkerd running. We have Linkerd Viz running. Let's get our application running. We're going to do that. We start by creating a namespace for faces, and then we put in this annotation on the whole namespace that says, hey, Linkerd, any pod that appears in this namespace via any mechanism whatsoever, make sure it has a running Linkerd microproxy. That's the easiest way to cause our whole application to get properly meshed. There are other ways, but this is the easy way. And then we're going to use Helm to install faces. That's the chart. we're explicitly telling it version 2.0.0-rc.2 because that's a good version to use for this, and because you have to be explicit about the version when you're using OCI charts. This tells Faces, hey, yeah, go ahead and let the GUI workload pretend to be the ingress, and these tell it, go ahead and enable Smiley 2 and Color 2. I deliberately didn't use a YAML file for that just because I wanted to be really obvious about what was going on. Oh, you know what? I should probably, never mind. I was going to say I should probably turn our names back on, but people probably know that I'm Flynn and you're Tom by this point. So let's wait for Faces to be running. That's good. And now that it is running, what we need to do to see Faces in the web browser is to connect to the Faces GUI service in the Faces namespace. How exactly you do this will vary depending on what kind of cluster you have. I am using a cluster on my local machine that's exposing port 80 of load balancer services as port 80 on localhost. So, oh, thanks, Tom. So that's how I'm going to do it. I just go to localhost, http://localhost. If you are using a cloud provider cluster, you should grab the external IP from the Faces GUI service in the Faces namespace. If you don't want to do that, you can use kubectl port forward, whatever works for you. But this is what you should see, something like that. You can already see that this does not look like a happy application because we're seeing lots of things up there that don't look like the little success graphic, which is the grinning face on a blue background. Lots and lots of problems. So one more simplification. We're not running Faces behind an ingress controller. You almost never want to do this, right? You should generally run your workloads behind ingress controllers that have been hardened for living out there on the internet. I am comfortable doing this with my particular cluster, both because there's nothing of any value whatsoever in it, and because it's running on my local machine behind my house firewall and my local machine's firewall. So I'm not too concerned about this one. But in general, this is a bad idea. Ingress controllers exist for a reason, and you should use one. Okay, so I just said Faces does not look good. So let's go and take a look at what we see in the Viz dashboard about what's going on here. All right, a couple of things. Immediately, we notice that, oh, hey, look, there is a Faces namespace that shows up in our Viz dashboard now. And we can also immediately see that it's showing us a success rate of only about 80% instead of 100%. So something is clearly wrong. If I click into that namespace, I can see that the Faces GUI, which is pretending to be an ingress controller, is talking to Face, which is talking to Color, and Face is also talking to Smiley. That's good. That's what we expect from our demo architecture. Also note, I don't see any edges in here for Color 2 and Smiley 2, which is also what we expect. If I scroll down here and I look at deployments, I see the fascinating thing that the only deployments that show me 100% success rate are the ones that are basically taking no traffic whatsoever. Mm-hmm. And everything else is showing me terrible, terrible results. I can also see the Faces GUI and Face workloads show about the same traffic volume, which is a little less than 8. And the other two show significantly less, which is kind of interesting. If we look back up here, we can see that Faces GUI talks to Face, but then Face is kind of the gatekeeper for Smiley and Color. So the fact that I'm seeing less traffic going to Smiley and Color implies that Face itself is probably failing part of the time. If I look over here at latency, all of the, like P50 latency looks pretty good, right? Half of our requests succeed fairly quickly. But if we look out at the P95 latency, 50% of the requests to this workload finish within the P50 latency, 95% within the P95 latency, 99% within the P99 latency. And when we get out to P95 and P99, they are awful. So we know that, yeah, there's some pretty significant trouble going on in these workloads. If I click into one of the workloads, let's pick on face, my little graph is replaced by a more detailed graph that shows me the golden metrics for the things that are talking to this workload and the things to which this workload is talking. Interesting point here is that color and smiley themselves are clearly failing a lot, even though they are the edges of our graph. So that might be a place to start. In the sense of, if we're trying to figure out what can I do to make this better, one of our strategies would be we could start at the edge of the graph as deep as we can go and then try to make that better and see if that cascades up. But since I can already see from the traffic requests that I suspect that the face workload itself is failing, I'll probably start with face and work my way down. If I come down here, I get to see live traffic that's happening. This is actually a table of the most common calls that are being made. So I can see that it's pretty common that the Faces GUI makes calls on /edge and /center. These are GET requests. Smiley, we talk to Smiley. We make requests GET /edge. But we also talk to color, and we do a post for color service edge, which looks a lot like a gRPC request, right? I get some latency information over here. I can see that all of these are happening a lot. I get to see the success rate. More interestingly, though, if I click on one of these, I now get to go and look at individual live requests as they happen. I'm not going to let that run for very long because I'll get overwhelmed. But here we can see, oh, look, HTTP 200, HTTP 500. Wait a minute. I can come and look at one of these and I get to see the headers of the request, the header of the response. I get to see what kind of status we got here. I can see that I don't have anything interesting about the gRPC status because this isn't a gRPC call. So there's a lot of stuff that we get to see just by looking at this in the web browser. If I click through and tap one of these gRPC edges, then I can see that all of these show an HTTP 200 response, but they don't all have the same gRPC status. So there's a fair amount of stuff we get to see about this just by looking at the Viz dashboard without really doing putting any more effort into it. Coming back, the main takeaway, like I was saying, is that Faces is in pretty bad shape. Really not doing very well. So the next question is, how can we make this better? One of the obvious things we could do is we could retry some of these failing calls. Or more accurately, we could retry some calls that we're pretty sure are failing anyway. So the first thing we're going to do is we're going to mark the face workload for retries. And we're going to do this by annotating the face service with this retry.linkerd.io. Oops. There's my cursor. This annotation tells Linkerd, hey, it's okay to retry any request to this service that gets an HTTP 5XX status code. And if I do this, then almost all of those frowning faces on purple background should just vanish. I say almost all because presently I'm limited to one retry, and the face workload will fail 20% of the time. With that kind of a failure rate, it's not hard to get 2 back-to-back failures. So you'll fail, we'll retry, you'll get another failure, and then we go, we give up. So if I bump the limit to 3, then that should pretty much take care of this entirely. And at this point, we really should not see those frowning faces on purple background show up. We might still see 1 or 2 as we go through the rest of the demo, but they're mostly just gone. And then Faces goes to prove me wrong. Thanks, Faces. Really appreciate that. Now, if we switch back to Linkerd Viz,
it's a good point. We didn't have to change the code at all, right? All we did was add annotations, which you can then go remove if you feel like it later at your convenience.
Which you should remove, actually, at your convenience after the developer fixes their buggy code, right?
Yep.
If we come back over here and we look back into the faces namespace again, an interesting thing is that we're going to see that the traffic to the face workload has just gone up. It used to be hovering a little bit below 8. Now it's around 10. And the reason, of course, is that retries increase load on the workload that had a less than 100% failure rate. So retries, when you get down to it, are really kind of all about protecting the user experience. They are not about protecting any of your workloads. And that's an important thing to remember about those. Next up, let's go after the cursing faces. The cursing face shows up when the face workload gets an error from the smiley workload. So we're going to do exactly the same thing and annotate smiley for retries. I should also point out that we're not limited to annotating services. We can annotate HTTP routes, for example, and we can make these much finer grained decisions, although we're not going to show that in this demo. But there we go. Lots of grinning faces. This is a good thing. The gray backgrounds are when face gets a failure from color. Color, remember, we talked to using gRPC. So the annotation now is different. Instead of saying HTTP 5XX, we say gRPC internal. gRPC purists, I realize internal is a bit of a heavy sledgehammer here, and I should probably not be returning internal errors from the color workload when it fails, but I decided I'd make it be really obnoxious. So when we do that, then this should make all of the gray backgrounds go away. And if we watch a little bit longer, it becomes fairly evident that that is not actually working. I will now put Tom on the spot. Tom, why don't you think this is working?
Oh my. I don't know. Go.
And for everybody watching who thinks I'm being unnecessarily mean to Tom, let me also point out that it took me, I want to say 10 or 15 minutes of poking around to figure out, to remind myself of what was going on down here. So yeah, what's happening is that unless we explicitly tell Linkerd, hey, this is a gRPC call, Linkerd usually treats gRPC calls as HTTP calls because they're just HTTP2 calls, right? They happen to use a post, they happen to have some other conventions, but we need to tell Linkerd this is gRPC traffic to unlock most of the really good gRPC functionality. The way we do that is by adding a gRPC route. So here's our gRPC route. We have two of them. They're both really simple. The one named color route says any traffic to the color service in the faces namespace should go to the color service in the faces namespace on port 8000 while we're at it, because that's the port we're using. So basically, this is a no-op gRPC route. This is saying if you are trying to send traffic to the color service, go ahead and allow it to go to the color service. The only purpose for this is to let Linkerd know, hey, there's gRPC going on here. Mm-hmm. We do the same thing for color 2. We have a color 2 route. Traffic presented to the color 2 service should be allowed to actually transit to the color 2 service. I'm being very careful in how I phrase things there because gRPC or gateway API routing for service meshes has some really fascinating subtleties. Tom and I were talking November or December or something like that about how, it's time to do a Service Mesh Academy that's just all about Gateway API. Mm-hmm. And I agree, it is time. But when we apply that to tell Linkerd, hey, this is all gRPC traffic, now we get all the blue backgrounds that we want because the retries start working because Linkerd knows to do gRPC things.
Yeah, and by using routes, you can do other things, right? Not just defining it for retries, but you can.
And we'll get to some of that.
Yeah. Okay. Cool. You're coming with that. Good.
We're coming with some of that. Nice. Another instructive thing here is we can go back to the Viz dashboard and we can see how our retries show up in Viz. And
sweet.
The short version is they don't. What we see is increased traffic volume, but we really don't see anything in here that, hey, dude, there are retries happening, which is an interesting limitation, honestly. So let's come back over here. We do have a really cool command line tool that we get to use to try to make some of this more clear, which is the Linkerd viz stat outbound command. If we run this, we get something that sadly doesn't fit very well in my terminal window, because my terminal has to be narrow enough that it can be big enough text that everybody can see it. So I have a Python script that just chops out the P95 and P99 latency so that it fits. And if we do that, we get to see both that, oh, hey, so traffic to color is being affected by the color route.
Mm-hmm.
The backend workload here is color 8000. That has an 80% success rate. But overall, we're retrying about, 20% of things. We can see that traffic to the backend, we get 9.07 requests per second, and that turns into 7.25 effective calls. 80% success rate for the real world, 100% effective success rate. And then the same thing for Smiley, which talks to the Smiley workload, has some retries, and we see pretty much exactly the same sort of thing. VizStat outbound is pretty new. I don't remember if it showed up in 2.15 or 2.16, but it's very new, and it is extremely cool. It also has a cousin, stat inbound, where you get to talk about inbound traffic to a particular workload instead of outbound traffic. So yeah, it's pretty awesome. Now, onward from there, there is a ton of other stuff that we can do with reliability mechanisms. In the interest of time, we're only going to show one other thing, which is dynamic request routing, which is what Tom was kind of mentioning, where we can also use route resources to take traffic going to a particular place and redirect it. So what we're going to do here is we're going to unilaterally change the world so that all our requests to Smiley instead get sent over to Smiley 2. And we do this by saying, oh, here's an HTTP route. Traffic presented to the Smiley service in the Faces namespace on port 80 is instead going to be sent to the Smiley 2 service. Unilaterally, as soon as we do this, we get all hard eyes instantly. Again, I want to point out, we have not touched the application code in any of this. It's all just running along, doing its thing. This brings us to an important point, which is that if you install a route like this, and then you just go away and leave it, 6 weeks later, some other person is going to show up and go, hey, it's time for me to go and update the Smiley workload. And they're going to update the Smiley workload. And then they're going to be really, really confused because they don't see any traffic going to Smiley. And their update has no effect. And they will have to go rummage around and figure out, oh man, we're redirecting everything over to Smiley 2 instead. And then start asking questions about, why are we doing that? When did we start doing that? So this is one of the many places where the power of the mesh introduces things that are operationally great, because, like if Smiley just starts dying at 8 p.m. on a Friday, you can go switch that over to use Smiley 2 instead, keep the application running over the weekend, and then bring the devs in on Monday to fix it.
Mm-hmm.
But you can also introduce some operational landmines if you don't clean up after yourself when you do that. That's a thing to be aware of. If we switch back to Viz at this point, then if we go back into the Faces namespace, then we will, actually, we waited long enough while I was talking for the traffic to the Smiley workload to fall away and all of it to be going to Smiley 2. Nice. I also want to point out, you still see that this is elevated. And when we go back and take a look at the browser, or take a look at Faces, we don't see any failures talking to our hard-eyed Smiley. So this is particularly interesting because Linkerd is still doing retries for the traffic going to Smiley, even though the traffic to Smiley is ultimately getting redirected to Smiley 2. Lots and lots of kind of fascinating combinations and things like that in here. We can also do much more fine-grained routing than just switching all the traffic. You remember when we were looking back in Viz, we saw that there were paths of /center and /edge. So /center is what the GUI makes. That's the call the GUI makes for those 4 cells in the center, these 4. And /edge is used for all the other ones. And so here we have one where this HTTP route, again, we're taking traffic directed to Smiley, but now we're throwing in 2 rules. The first one has a matches clause to say, if the path prefix is /edge, then take this traffic to Smiley 2. Otherwise, if that match fails, the fallback is go to Smiley instead. So when we install this route, our central 4 cells should revert to the grinning smileys, while our edge cells stay as hard eyes. Like that. We have the same thing for the color workload, by the way, where we have a gRPC method of center or edge. And so this one, we can change our color route so that if the method matches center, we will go to color 2, which should be green. And if it doesn't match, we'll stick with color, which is blue. If we apply that one, then again, we will immediately see the central cells switch over to green. I want to point out here that these take effect immediately. The proxies just get to instantly start shifting traffic around. And again, haven't changed the application at all. All right. Finally, last thing we're going to show off in the demo. We talked briefly about authentication and authorization for workloads. So I was a little torn about demoing this because auth policy is the most complex thing that you have to configure in Linkerd. But there's a way we can do this pretty simply. What we're going to do is we're going to set up an auth policy to demo requiring a particular service account to allow the Faces GUI to talk to the face workload. So this YAML looks ugly, but it's not actually all that bad. We have 3 different resources here. The first one is a server, which is actually all of these are Linkerd specific resources. So we have a server named face HTTP that basically is matching traffic to any pod with the service face label, which is to say the face workload in this example, on the port named HTTP. So this is matching any HTTP traffic being sent to the face workload. And by default, we will deny that traffic. Next up, we have a mesh TLS authentication. This is a resource that says to match this authentication, you have to be using the identity whose name is facesGUI.faces.serviceaccount.identity.linkerd.cluster.local, much of which is boilerplate. The important thing here is that's the service account whose name is Faces GUI in the Faces namespace of our cluster. Any traffic from a workload with that service account will match that mesh TLS authentication. Any traffic from anything else will not match it. The final one here is the authorization policy, where we say, in order to talk to the Face HTTP server, in order to send HTTP traffic to the Face workload, you must match the mesh TLS authentication named Face authn, which is to say you have to be using a service account named Faces GUI in the Faces namespace. Okay. The moment I apply this, everything will break. Excellent. We've just broken the world. The reason that it breaks is that the Faces GUI workload is currently not using a service account named Faces GUI. It's currently using the default. We can verify this with the Linkerd identity command. And what we're doing here is saying, show me the identity for all the pods matching the service Faces GUI label in the Faces namespace. And if I do that, I get a ton of stuff because it shows me the entire certificate. So I will rerun that, and I will only look at the subject line because that's the one that we really care about. That tells us the name of the identity that it's using. And it is, in fact, default.faces.serviceaccount.identity.linkerd.cluster.local. And that is why everything is broken. To fix this, we first are going to create a service account named Faces GUI. There isn't one right now. And then we're going to switch the Faces GUI workload to use it using kubectl set service account. That requires restarting a pod, so this will take a few seconds, but now everything will start working again. All right. And there we go. Whirlwind tour of kind of just the basics. There's a ton of other stuff we could go into here. Dynamic request routing dovetails really nicely with progressive delivery and GitOps and all this kind of stuff. So you could be doing A/B testing far down in the call graph, which is really cool. Linkerd, as I mentioned, we support timeout, circuit breaking, rate limiting, egress controls, a bunch of other stuff. We can do multi-cluster. We can do mesh expansion. We have the Buoyant Lifecycle Operator as part of Bell, which can do really awesome things where you edit a CRD and all of the versions of your proxies change. We've got extra cross-zone traffic capabilities with Hazel and Bell. And Bell also includes policy generation tools, which make a bunch of this complex policy stuff easier. We have covered most of these sort of to some extent in previous SMAs, and we will be covering more of them in future SMAs. All right, but that is the end of our demo here. So let's duck back and really quickly talk about some gotchas and things like that. The biggest ones for this workshop are the simplifications that we called out in the demo, where you really don't want to be using the Linkerd CLI to manage things like certificates for you. That is not a good idea. You do not want Linkerd Viz managing Prometheus. These topics are absolutely worth their very own Service Mesh Academy. We have done their very own Service Mesh Academy on some of them. So here are a few that you could go and get started with. If you go and just go to the main Service Mesh Academy repo, you'll see a big list in the main README that will point you to these. So you'll find one named Metrics and Dashboards and Charts, oh my, which is the one for the QR code on the left. But you can just go through and pick and choose from anything that you think is interesting there. More specific gotchas beyond just we simplified some stuff. The Viz dashboard is really cool. It does not have support for everything that you want to see at this point, which is kind of sad. Linkerd Viz stat outbound, which we showed in the demo, and its cousin stat or sibling stat inbound are wonderful tools for this. So I highly recommend playing with those as well. Remember, if you're trying to use advanced gRPC functionality, you will need to create gRPC routes. Very important thing, very easy to miss. All of us get tripped up by that on a regular basis. Finally, when you're working with auth, take it slow, take it a step at a time. For the love of all that is holy, do not try to go and put authentication policies onto your entire application all at once. That will not end well. We didn't really cover audit mode in here, but that QR code will take you to the link for it. The short version is, instead of saying access, was it default access deny? Mm-hmm. You set it to audit instead of deny, and it will go nicely.
Yeah, there's some things that can happen that you might not be aware. Like if you've got, protocol detection errors, it'll upgrade those to TCP. And if you don't have auth policies for TCP, all of a sudden traffic gets denied. So you want to see how this goes, and you keep working it and, massaging it until it's giving you what you want. And audit mode was enormous. We just introduced that recently, and that's
I think that was 2.16. Yeah, it's a huge win.
For being able to just make sure that when you go live with this stuff, you're not going to break anything. It's really, really big. The other thing is with routes, there's some useful, just besides just routing traffic, routes are great when you combine it with metrics. So you can break metrics out into specific routes and buckets to either monitor or to ignore traffic, set traffic aside if there's stuff you don't want to be, because by default, you'll get a default bucket and you'll get a probe bucket. And not everybody wants to see every bit of traffic in one place. So routes are pretty handy to use for a lot of different things, but that's one that we have a lot of customers using.
And we talk about that in the metrics and dashboards and charts. Oh my.
That's SMA. A great one.
Highly recommended.
Yep.
And not just because Tom and I did it. It was,
And certificates, there's a lot of different ways you can do that. We have customers, but we integrate with Cert Manager, which will open the door to a lot of other ways of managing certificates and issuing them. So definitely take a look into that, because once you're ready to go into production, that's something that you want to make sure you get right, and that it's going to make your security people happy.
A lot of room for another security and certificate management SMA too.
Yeah.
Okay. Finally, last couple of minutes here. Please go and fill out the feedback form.
Please.
Do we have a caption for the feedback form?
A caption. I've got this. Yeah, let me go throw this QR code up. This is the QR code that you probably already have.
Yeah, it's hopefully should go to the same place as the one there on the slide. we'll leave the smaller one up there right now. Buoyant Enterprise for Linkerd. I demoed it here. It has good stuff in it. Go check it out. We have the Service Mesh 101 online course, and soon we will have the Linkerd in Production online course. Go check those out at learn.buoyant.io. Our next Service Mesh Academy, we'll be talking about open telemetry with Michele Mancioppi of -0. That one should be kind of fun. And so far, the question I'm seeing in Slack boils down to a place where I pretty clearly called Python instead of Python 3 in part of the demo, so I shall have to fix that.
Apologies.
Sorry about that. Anything else? Now is a good time.
Yeah, really looking forward to the open telemetry.
Yeah, that should
tracing is one of those things that we're just starting to see a lot of customers, get interested in, and it's super helpful, right? Where are things breaking? And that's an area where we're, again, get familiar with the Linkerd command line and know the options, because a lot of times before you're going to implement things at a high level, you really want to be able to do them down at the CLI level. And that's something where we're putting some effort into, improving the experience there, and being able to do things like tracing from the CLI and things are going to be huge for folks. So when you're in that moment, you're trying to fix something, it's really handy to be able to just do a quick spot check on it, right? Before you go and try and build something more complicated on top of that.
Yeah, I'm looking forward to some of the things coming in the CLI actually as well. That should be nice.
Oh yeah.
All right. Well, if you have questions, please bring them over to the workshops channel.
Let me throw that back up one more time. Let's see here. There we go.
Thank you. We will be there for the foreseeable future. So if you have questions, bring them there. We can answer them. I think we're going to go ahead and drop the stream. Thanks, everybody, for attending. We very much appreciate it. And we very, very much want to see... Oh, wait, I just found the chat. Oh, good. On the chat, we have somebody saying that they are, in fact, able to take this course on the O'Reilly platform, which is wonderful. Excellent.
Nice.
Glad to see it.
Nice.
Yeah. All right. And on that note, we will see y'all in February. Much appreciated, everyone.
Get signed up now for February 13th, open telemetry.
Yep.
And we'll see you then.
Have a good one.